Okay, so hello everyone. Welcome to this course on coordinate geometry. So, here, what I'm going to do in this course is that I'm going to follow this book, The Elements of Coordinate Geometry. Okay, I'm sure most of the students who are well versed with plus 2 mathematics or are preparing for competitive exams in India like JEE Advanced, JEE Mains, and various other competitive exams. I'm sure you must have heard about this book. But what happens is nowadays in the digital age, we do not really have the patience to go through the whole book, okay, solve all the problems of the book. So, what I'm going to do is I'm going to make your life a bit easier by making videos of all theory. Okay, I'm going to cover all the theory which has been covered in this book, along with all the exercises. Okay, along with all the exercises with the solutions. So I'm telling you, if you go through this course, I'm sure by the end of this course, you will have a very good grip of coordinate geometry and have a very strong foundational understanding of this subject. So, see, I'm sure that a lot of people already have idea about coordinate geometry and you have already learned this subject from your various teachers or various other textbooks, school textbooks, etc. But what I'm going to do, I'm requesting you to empty your mind and start afresh. Okay, start this course afresh without using your previous knowledge. Okay, you will see that you will enjoy this course much better. Also, here I'm not going to use any slides or anything of that sort because when I was a student at that time, I used to feel that the professors or the teachers who used to teach through the help of slides, it's less engaging. However, what I'm going to do is I'm going to write down the concepts. I'm going to write, and I will expect the viewers of this course to take notes so that they can use it to the fullest extent. Anyway, without any further ado, what I'm going to do is that I'm going to start this course on coordinate geometry. So I'm sure that most of the people are already aware of what coordinate geometry is and what are the major components of this. So this is what we are going to cover in this course. Okay, this is what we are going to cover in this course. So first thing that we are going to cover is basically the basics of coordinate geometry. What do you mean by basics of coordinate geometry? In basics of coordinate geometry, we're going to learn about the concept of Cartesian coordinates, which will be in this video itself. And then we will move into the concepts of areas of triangles, how to find the distance between 2 points. There is something called the section formula and related concepts. So that we are going to cover in this first part, that is basics of coordinate geometry. Then we will start with this chapter called straight lines. Very interesting chapter, very easy chapter as well. Okay, however, a very important chapter from the point of view of competitive exams. Okay, then thirdly, we will cover this chapter called pair of straight lines. We are going to cover this chapter of pair of straight lines. So in this chapter, pair of straight lines, we are not going to talk only about single straight lines, but a combination of two straight lines, which is represented by certain equations. Don't worry if you are finding this gibberish. You will understand everything once we cover all the concepts. Okay. Then after that, we will move into the circle. Then after that, we will move into the conic section. Okay, technically conic section also includes circles as pair of straight lines. However, under conic section, we are going to cover three important things. That is parabola, second is ellipse, and third is hyperbola. So these are the three important chapters that we are going to cover under conic section. So who are going to be the major target audience for this course? So I would say that any student who is willing to learn coordinate geometry, it's going to help you in your school exams. It's going to help you crack any competitive exams. Okay. Now, since I'm an Indian, I will talk from a India point of view. So the various competitive exams that will be coming under the purview of this course will be, of course, we will have the exams like JEE Mains, JEE Advanced. Nowadays, the MBA entrance examinations. Okay, all the MBA entrance examinations, uh, for example, CAT, you have ZAT, okay, the one for XLRI, and various other entrance examinations you have the IPM80, okay, which is the 5-year integrated course in management in various IIMs, initially started by IIM Indore. So this then we can also talk about other exams like CLAT, etc. Okay, wherever there is mathematics and logic is required, coordinate geometry nowadays is a very integral part of this competitive exam structure. So coordinate geometry is going to be a great help. This lecture series, this video series is going to be a great help to all the students who are targeting these entrance examinations along with other entrance examinations. Apart from that, we will also say that it will help in your class 11, class 12 board exams, class 12 board exams, and class 11 exams of your school. So from class 12 point of view, many people might be saying that in class 12 we do not have coordinate geometry. How is this course going to help? Actually, the concepts of coordinate geometry are not limited and independent. They have a variety of applications in various topics of mathematics and various other subjects. Okay, so you are going to use the concepts of coordinate geometry in the chapters of vectors and 3D geometry, in the chapters of trigonometry, in the chapters which are related to physics like vectors and stuff. Okay, people who study economics in macro and microeconomics, all the supply demand functions, utility curves. Okay, and then in macroeconomics you have ISLM curve, all these things. Okay, everything is going to use coordinate geometry. Later on, you will find it extremely easy to follow a course on linear algebra. Okay, if you have the basic foundational knowledge of coordinate geometry, right? Okay, in physics and chemistry, of course, you're going to use this a lot. For example, in kinematics, you're going to use it for the speed, distance, time graph. I'm sure already many people who are learning physics have already come across those things. Then we are also going to use the concept of coordinate geometry in chemistry as well, where there will be multiple graphs. It's very important that you know how to interpret the graphs. And of course, data interpretation is one of the hot topics in today's world. So it is very much important and necessary. Anyway, without further ado, let's start the course on coordinate geometry. All right. So everybody excited? I hope you are. So let's get started. So, first of all, I'm going to start with chapter number. I'm going to start with chapter number 2. If you open the book, okay, you will see that chapter number 1 is a chapter which creates your basic algebraic foundations. Okay. Uh, I'm assuming that you already are aware of various algebraic foundations, and there are certain concepts related to matrices and determinants which are covered. However, those concepts I will tell you as and when it is required in this course. Okay, so we are going to skip chapter 1. We will directly move into chapter number 2, where actual coordinate geometry takes proper shape. So the name of this chapter is coordinates. Everybody start writing along with me in your notebooks. Okay. Coordinates. Then we have lengths. We have lengths of straight lines. And areas of triangles. Okay, this is the name of the chapter over here. This is the name of the chapter. It is coordinates, lengths of straight lines, and areas of triangle. So in today's class, I'm going to mainly focus on this part of the chapter. That is coordinates. All right. So before I start the chapter, anybody has any idea about what are we going to do in coordinate geometry? I'm sure you have learned about, all these concepts before in your school. Okay, what concepts am I talking about? You must have learned about congruency of triangles. You must have learned about similarity of triangles. Okay, then you must have learned about quadrilaterals. Okay, then also you must have learned about circles, various geometric theorems related to circles and tangents, right? Parallelograms, blah, blah, blah. You must have learned all these things. All of these things, okay, where you're purely dealing with this plane geometry, this will come under the purview of Euclidean geometry. Okay. All of the things that you have learned in class 10 in geometry, they are Euclidean geometry. But what we are going to learn now is something called the coordinate geometry. So what do you mean by this term coordinate geometry? In coordinate geometry, or many places you will find the reference to this word, analytical geometry. So this is basically nothing but an amalgamation. Okay, it is an amalgamation of two things. That is, normal geometry as we know it. Along with that, we basically use equations of algebra to represent figures. Okay, so it is an amalgamation of geometry and algebra. That's going to give me this new field called coordinate geometry. Okay, so first of all, let's start with the concept of coordinates. Okay, so you must have seen your x-axis and y-axis in this manner. Okay, you must have seen you have x-axis, you have a y-axis like this, right? So you basically write it something of this sort. You write this as the origin, this is x-axis, this is x bar, this is y, and this is y bar, right? And it is assumed that this angle over here is 90 degrees. Okay. See, this is how we have been generally taught, that this is the x-axis, this is the y-axis, and they're always 90 degrees. The axes are always making an angle of 90 degrees with each other. However, that's not always true. In coordinate geometry, you can also have, let's say x-axis is this, and you can also have your y-axis something in this manner. Okay, this can be your y-axis. This can be your y-axis. This is your x-axis. Okay, where you have an angle omega which is being made. Okay, generally we represent this angle as omega. So if this omega is equal to 90 degrees, okay, then we call this as the, okay, rectangular coordinate system. Okay, we call this as the rectangular Cartesian coordinate system. Okay, and in the other case here we call this as the system of oblique axis. We call this as the system of oblique axis when omega is not equal to 90 degrees. This is when we call it as a oblique axis. Okay, so do you see this word Cartesian? Where do you get this word Cartesian from? So there was this philosopher whose name is Rene Descartes. I'm not sure of the pronunciation or the, you know, the accent marks. Anyway, so what this guy did, this guy was the first person who initially introduced the concept of coordinates and the Cartesian coordinate system. Hence, the name has been like this, that is Cartesian, from the philosopher's name Rene Descartes. Okay, so it's a brief introduction. Okay, I'm quickly going to go through the concepts which are related to this one. Just for the sake of the fact that we can also have oblique axis, I'm going to build upon the basic concepts around coordinate geometry of coordinates with oblique axis instead of a rectangular Cartesian coordinate system. Okay, so let's get started with that. So first of all, what I'm going to do, I'm going to consider a x-axis like this. Okay, another line I will consider something like this. Okay, this is going to be your y-axis. Okay, so and this point of intersection of these two lines, let's call it O. Okay, so this side it's going to be x, this side it's going to be y, and they are at an angle of something. Okay, so this line we will call as the x-axis, and this line we will call as the y-axis. Simple. Okay, and these two together, the x-axis and the y-axis, these two together are going to be known as the axis of coordinates. The axis of coordinates, or you can also say the coordinate axis. Okay, you can also say the coordinate axis or the axis of coordinates. Okay, now this point O is called the origin. Okay, this point O over here, this point is called the origin of the coordinates, or we can just refer to it as origin. Okay, now let's assume there is a point P over here. Okay, there is a point P over here. Now what I'm going to do is that I'm going to draw a straight line which is parallel to the y-axis. Okay, I'm going to draw a straight line which is parallel. This line and this line are parallel to the y-axis, and let's consider the point of intersection of P and the x-axis as M. Okay, and now this distance that you see, okay, this distance OM, okay, this distance over here is known as abscissa. Okay, the distance from the origin to point M, okay, is known as the abscissa. And this distance MP that you see over here, okay, this distance is known as the ordinate. Okay, this distance is known as the ordinates. And the abscissa and the ordinate, Okay, the abscissa and the ordinate, they together form the coordinates. They together form the coordinates. Okay, so you need to remember, you need to know this. Okay, that is that if I have, okay, any distance which is measured parallel to the x-axis, okay, any distance, any distance which is measured parallel to the x-axis, this will be denoted by either x or x1, x2 and so on, or it can be denoted by x bar, x double bar and so on, x prime, x double prime and so on. Okay, similarly, if I talk about any distance which is measured parallel to the y-axis, okay, then it is represented by y, or y1, y2 and so on, or it can be represented by y prime, y double prime, y triple prime and so on in this manner. Okay, so now if the distances, okay, that is OM and MP in this figure that you see, okay, they are x and y. Okay, let's say this distance is x and this distance is y. Okay, then the point P, okay, then the point P has a coordinate of x comma y. Okay, so always remember something over here, that first we will write the x coordinate or the abscissa, and only after that I will write the second coordinate or the ordinate. Okay, the second coordinate, which is the ordinate. Okay, so for brevity purpose we use it in this manner. Okay, that is P is x comma y. Now what does this mean? If I say, that in a coordinate system, let me draw another. Let's say I draw it like this time. Let's say like this. Okay, and let's say this is your x-axis, this is your y-axis. Okay, and let's say I have a point over here which says 1 comma 2. What does that mean? Let's say I have this point P over here. Let's say I have P over here. P is 1 comma 2. What does that mean? That basically means that if you draw a line parallel to the y-axis, okay, then this distance, okay, this distance over here is 1 unit, okay, and this distance over here is 2 units. So the any point x comma y is basically representative of the position. Okay, it is basically representative of the position. So any coordinate x comma y, it is going to, it tells us about the position of a point in the plane over here. Okay, x comma y, it basically tells us about the position of a point in the plane. I hope this is clear to everybody. Okay, so in this case, clearly, my OM is half the size of PM. Okay, that's just for observation purpose. Okay, I hope this point is clear to everybody. Okay, so now let's move forward and understand the concept of the quadrants. Okay, understand the concept of the quadrants. Okay, so now let's move on to our normal rectangular Cartesian coordinate system only, because in this course mainly we will be talking about rectangular Cartesian coordinate system. Rectangular as in you have your y-axis like this. What happened to this? Okay, I'm not sure why this is appearing, but yeah. Okay, line tool is not working. But anyway, so suppose, let's say you have your x-axis like this, and you have your y-axis somewhat like this. This is your x-axis, this is your y-axis. Okay, this is making some problem. Anyway, so let's do it once again. Let's try it once again. So let's say this is your x-axis, yeah, and this is your y-axis. And this time I am drawing them perpendicular to each other. All right. So in this course, I would just want you to mark these two arrows, and that should be fine. Okay, where this will be the origin, this is the x-axis, this is the y-axis. You need not always mark them as well. Okay. However, if you extend this line till x prime like this, and extend this line as y prime like this. Okay, so this basically means that any line, okay, any distance which is measured above the x-axis is going to be taken as positive. Okay, the value of the distance should be positive. Okay, the value of the distance in the downward side is always going to be negative, just for the position purpose. Distances cannot be negative actually. Okay, you must have learned this in physics. Distances cannot be negative. Okay, however, to determine the position of it, that whether something is lying above the x-axis or below the x-axis, anything which is above the x-axis is a convention. We take it as positive, and anything which is below the x-axis as a convention, we take it as negative. Okay, similarly, for the y-axis, similar thing holds. Anything to the right of the y-axis is going to be taken as positive. Anything to the left of the y-axis is going to be taken as negative. Okay, I hope this is absolutely clear. Okay, so let's say I have a, let's just consider a system like this. Okay, this is, I'm assuming they are 90 degrees to each other. Okay, and y dash. Okay, so any distance, let's say there is this point over here, n. Okay, this point n is, let's say, 3 units to the left of O. Okay, and it is 4 units to the above of O. Okay, so anything which is above O. Okay, first of all, we write down the x coordinate and then the y coordinate. First we write down the abscissa and then we write down the ordinate. Okay, so I want to write down the coordinates of this point n. So n is going to have 2 components, the x coordinate and the y coordinate. What will be the x coordinate? Is it going to be 3? It's not going to be 3, because we are moving to the left. We are moving to the left of the y-axis. So it's going to be negative. So it is going to be negative 3. But for y-axis, you see that we are moving up. We are moving up. Hence, it's going to be positive 4 only. Okay. Let's do some practice of this. Okay, then we will be clear about this. Okay, let's understand the concept of quadrants. Okay, so let's say this is the x-axis, this is the y-axis. Okay, just for the sake of it, I will mark the arrows so that there is no confusion. Okay, so anything which is lying in this yellow colored space. Okay, anything which is lying in this yellow colored space, the x-axis is going to be positive and the y-axis is also going to be positive. Okay, the x coordinate, that is the abscissa, is going to be positive, and the ordinate is also going to be positive over here. And this quadrant over here is known as the first quadrant. Okay, let me shift this a little bit so that we have space. Okay, so this is the first quadrant. First quadrant, x coordinate is positive, y coordinate is positive. Okay, then we have the second quadrant. This is the second quadrant. In the second quadrant, you can see that it is to the left of the origin. Hence, x-axis is going to be, x coordinate is going to be negative, and y coordinate, whereas, is still lying above the x-axis, so it's going to be positive. So here, what is happening? Your abscissa is less than equal to 0. Your ordinate is going to be positive, greater than or equal to 0. Okay, and this quadrant over here is known as the second quadrant. This quadrant over here is known as the second quadrant. Then we move on to this quadrant. In this quadrant, you can see that both are negative. Okay, it is below the x-axis, it is to the left of the y-axis. So x coordinate is negative, y coordinate is also going to be negative. Okay, so here what is happening? The abscissa is going to be less than equal to 0. The ordinate is also going to be less than 0. And this is called the third quadrant. This is called the third quadrant. And finally, we have this quadrant. Okay, in this quadrant, you can see that towards x-axis it is positive. So x coordinate is positive. Y coordinate is below x-axis, so it is going to be negative. So here abscissa is going to be greater than 0, but ordinate is going to be less than or equal to 0. And this quadrant we refer to as the fourth quadrant. Okay, we refer to this quadrant as the fourth quadrant. So these are the quadrants and their sign notations. Okay, any point which is on the first quadrant is always going to be two positive numbers. Any point which is in the second quadrant is always going to be a combination of a negative x axis number and a positive y axis number. Okay, similarly for third quadrant and fourth quadrant. Okay, I hope this is clear to everybody over here. All right, so since we have learned about this concept, okay, what we are going to do, let's practice a few small problem. Okay, a small problem we can practice over here. So let's say that I have my x-axis over here, the y-axis is over here. Okay, as given in the book. Okay, we'll practice the example. Okay, there is this point. Okay, there is this point 2 comma negative 1. Okay, 2 comma negative 1. I need to locate where this point is. See, it's very simple. If I'm talking about 2 comma negative 1, the simple trick is that first of all 2 is there is no negative sign. So it's going to be towards the positive x-axis. Which part is the positive x-axis? You see, anything over here. Okay, this is the positive x-axis. And anything over here, this is the negative x-axis. Okay, so first of all, it is going to lie on this side. Okay, it's going to lie on this side. And negative 1 means towards the down. Negative 1 this side. So what's going to happen? I'm going to move 2 units in this direction and 1 unit in this direction, and this point over here is going to be 2 comma negative 1, and this is going to lie in the fourth quadrant. Similarly, next another question is given. Okay, you need to plot the point minus 3 comma 2. So how are you going to do minus 3 comma 2? Minus 3 means negative x-axis. So on the negative side of the x-axis, I'm going to move 3 units. On the positive side of the y-axis, I'm going to move 2 units. And this point over here is going to be negative 3 comma 2. Next, we have negative 2 comma negative 3. What do we do about this? 3 units to the negative x-axis direction, sorry, 2 units to the negative x-axis direction, and 3 units to the negative y-axis direction. It should lie somewhere over here, negative 2 comma negative 3. See, it's very easy. Okay, I'm sure most of the people are already aware of these concepts, and you are finding it very easy to follow over here. Okay, and that will be mostly the introduction to coordinate system. Okay, so we have learned about, so let's quickly have a revision of what we did. Okay, we started off the course. We talked about the rectangular coordinate system. We talked about oblique axis, x-axis, y-axis, abscissa ordinate. Okay, all of these concepts are being talked about. And after that, we talked about the concept of the axis, the sign convention. Okay, in this case, you can give the heading over here as sign convention in a coordinate system. And here we took an example, and then we moved into the concept of quadrants, and we took the example which is there. Okay, if you see in your book, it should be around 17 number example. Okay, it should be 17 number example. Okay, so you will find this. Anyway, so in the next lecture, what we are going to cover? In the next lecture, we are going to cover the concept of distance formula. Okay, the concept of distance formula. And after distance formula, we will move into another, another concept, which is called the section formula. And we will also do some questions so that we understand the concepts. All right. Okay. So, and after that, we have the examples. In fact, the exercises, we will try to cover most of the exercises which are there in the book. Okay. So, anyway, we will now end this lecture. Thank you so much for watching, and see you in the next lecture. Thank you.